All right, so a couple more problems with some more details. This one here, I want you to be careful about carrying this 2 along. So you've got to split it up around this addition and subtraction in the numerator in order to take the antiderivative. So I'm going to go super slow. Minus x over 2x squared plus 2 over 2x squared. Least amount of mistakes if you write the little steps down. So this turns out to be just a 1/2. This turns into a 1/2 times a 1 over x. I like to separate that so that I can see the ln of x there, right? Because I know the antiderivative of 1 over x. And then this here, the 2's cancel, and so I'm going to rewrite this as x to the negative 2 so that I'm ready to take the antiderivative in the next step. All right, so let's do it. So the antiderivative of a number is 1/2 x. This I carry the 1/2 along, or the negative 1/2. And then I have ln of x, absolute value. Add 1 to the exponent, so I get x to the negative 1 over negative 1. And so that's between 1 and 2. All right, so 1/2 x minus 1/2 ln of x. I'm just going to take one step to rewrite this term here, so it's negative 1 over x. Evaluate between 1 and 2. So if I plug in the 2, I get 1 minus 1/2 ln of 2. And 2, absolute value of 2 is 2, so I can leave it like that, minus 1/2, subtract off, plugging in 1, so I get 1/2 minus ln of 1, which I know is 0, minus 1. So this term is 0. So I have 1 minus 1/2, so that's 1/2 minus 1/2 ln of 2. And inside here, this is 0, so I have 1/2 minus 1. So that's a negative 1/2 with a negative, so that's a positive 1/2. So all told, I get 1 minus 1/2 ln of 2. All right, this one here, I want to rewrite this so that I have the x's in the numerator as x to the negative 1/2. And then this 3/4, I'm just going to leave that x in the denominator because I know that's ln of x coming up. So this is x to the 1/2 over 1/2. Oh dear. Over 1/2 minus 3/4, and then this gives me ln of the absolute value of x between 4 and 8. All right, so I'm going to bring this 2 up here, so that gives you a 4. And then I'm going to be evaluating at 8, so I get square root of 8 minus 3/4 ln of x. ln of 8. Subtract off, sorry, that's really messy. Okay, so ln of 8, absolute value of 8 is 8, right? So that's me plugging in 8 into here. Subtract off, now plugging in 4. So this here gives me a 4 root 4 minus 3/4 ln of 4. So this gives me 2 root 2, so I'd get 8 root 2 minus 3/4 ln of 8 minus this in total gives me an 8, and then plus a 3/4 ln of 4. And that's as simplified as that one gets. This one here, you must multiply it out first so that you can integrate it term by term. So 0 to 1, so I'd have 3. I'd add these exponents together, so I get x to the 3/2. And then minus, so I would get 6x over 5x, right? dx. So I just kind of went slow there to make sure I did everything correct. Those cancel. So now take the antiderivative. So I get x to the 5/2 times 2/5. And then here I would just get 6/5 x from 0 to 1. So then plug in 1, so 6/5 minus 6/5, I get 0. All right, one more. Taking the antiderivative of secant squared is tangent. Antiderivative of negative 2 sine will be positive 2 cosine because the derivative of this gives me this. And then the derivative of the constant here, because I'm in theta land, it's 3 theta, not 3x. And then I'm evaluating between 0 and pi over 4. So I plug in pi over 4, I get tangent of pi over 4, cosine of pi over 4, minus 3 times pi over 4. Be careful, because not everything is 0 when I plug in 0, right? Tangent is 0. That does give me a 0. Cosine of 0, whoops, 2 cosine of 0 does not give me 0. So cosine of 0, then minus 0. Okay, so tangent of pi over 4 is 1. This gives me 2 root 2 over 2 minus 3 pi over 4. And from here, I get a subtract a 2. So I guess we could fix this up a little bit. So I'd have a negative 1 plus 2 root 2 over 2 minus 3 pi over 4. And we are finished.